In this video, we're going to determine and interpret coefficients of determination and the standard error of estimate from 9.3. Let's go ahead and get started. The coefficient of determination r squared is the ratio of the explained variation to the total variation. That's our first question. And then what does it measure? The coefficient of determination is the percent of variation of y that is explained by the relationship between x and y. And 1 minus r squared is the percent of variation that is unexplained by the relationship between x and y due to other factors. So what is the coefficient of determination for two variables that have a perfect positive linear correlation or perfect negative linear correlation? Two variables that have a perfect positive or perfect negative linear correlation have a correlation coefficient of 1 or -1 respectively. In either case, the coefficient of determination is 1 because 1 squared is 1 and -1 squared is also 1. That means that 100% of the variation in the response variable y is explained by the variation in the explanatory variable x. So now let's go ahead and come up with some calculations here. If we have r, let's find r squared and round this to 3 decimal places is 0.070. So that means 7.0% of the variation in y can be explained by the relationship between x and y, and 93.0% of the variation in y cannot be explained by the relationship between x and y and is due to other factors such as sampling errors, coincidence, or lurking variables. Now let's deal with this one, -0.971 squared. It's going to be 0.943, which means 94.3% of the change in y can be explained by the change in x, and 5.7% of the change in y cannot be explained by the change in x. Is due to other factors like those we've talked about. I've gone ahead and typed this data in already for us into stat edit into my lists here. We'll talk about what L3 is here in a minute, and it has to do with this regression equation here. So second quit, I'm going to go to stat tests and I'm going to run my linear regression t-test that we've been doing already in this chapter for L1 and L2. Let's go ahead and put that regression equation into vars, y-vars function y1. Let's calculate here. And that gives me an r squared. I come down here of 0.773. Let's fill in those blanks there for numbers 1, 2, 3, and 4. The fraction of variation in the amount of imported crude oil, which is y, that can be explained by the variation in the amount of produced crude oil x, is r squared. The remaining fraction, 1 minus r squared, of the variation is unexplained and is due to other factors or to sampling error. Now let's go ahead and look right here. This S right here is my sampling error. Sorry, my standard error, which is 222.070. I'll show you another way to find that by hand in just a second, but that's the easiest way to get it from the calculator. And the standard error of estimate of the amount of imported crude oil, which is y, for a specific amount of produced crude oil x, is S sub B here, and S sub B is measured in thousands of barrels per day. There we go. Now let's talk about how to get that 222.070 0.070 by hand because there's a reason they gave you this regression equation. I just went ahead and stored the regression equation here from the calculator. It's the same thing, just to more decimal places. So I came in here, stat, edit, and I want my values here come from the equation of S sub E equals square root of the sum of the yi's minus the y hat i's squared over n minus 2. So let's see if I can get that typed in right here into the calculator. Clear enter. Hopefully I come up with the same list again. Is going to be, let's just get this part that's inside the summation here. So the yi's are going to be L2 minus, and then to get the y hat i's, I'm going to do vars, y vars function y1, where I just put my regression equation. We're going to calculate the y values for these x values that are in L1. Close that up, close that up. That gives me what's inside the parentheses here. And I want to square that. And that's how I got that list there. I'm going to come out here and I'm going to take the sum of what's in L3 and I'm going to divide it by 7 minus 2 is 5. And then I'm going to take the square root of that answer. And that gets me my 222.070 that I have there. And that's the correct way to do it. To get this answer, though, it's just as easy to come in here and let the calculator do it for you. Just you need to know whether your teacher is going to make you show any of that work. So when we come in here and run this linear regression test like this, we get it. I think we also get it when we do a linear regression interval. Doesn't matter what your confidence level is. Yes, there it is right there. So either way, whether you do a confidence interval for your linear regression or you do a hypothesis test for your linear regression, it calculates your S sub E, your standard error of estimate, as well as your R and R squared values that you might need. All right, that is it for this video. That's everything for chapter 9. That's also everything for our Math 245 topics. I hope this has been helpful to you, and see you next time.